So the last aspect of Liferay that we're going to be looking at is searching and indexing. So how are we able to customize those specific things? First question, why do we really need a search engine in the first place? Search engines provide a lot of the heavy lifting of searching and indexing in the first place, right? And so when using a search engine, there's a lot of algorithms and logic behind the scenes so that the indexing process is optimized. It's much faster. Search engines can also make the whole process configurable so we can change what's going on to our different use cases, our different needs, right? Search engines also provide a way to kind of sort through the results as we're searching based off of, is this relevant? And based off a score, maybe we want to do something different. And we can have advanced querying like fuzzy search, right? You search for something, maybe you might get something close or relevant to it. So besides a lot of different features, searching in the database is not exactly the best thing. When working with relational databases, they're not really designed for us to search them. And because of that, the performance of searching within a database is much more taxing compared to just using a search engine. So the search engines that Liferay do support, we have Elasticsearch as our default, and we also have Solr, and we have a connector that can connect Liferay and Solr together. But our preference and what we recommend is Elasticsearch, but you are able to use Solr as well. So when we're using Elasticsearch, there are two modes of operation. We have embedded and we have remote. We use embedded to just kind of play around, right? When we're developing, when we're in our testing stages, the embedded is fine and dandy. But once we move on to production, we always want to use the remote Elasticsearch mode. So that way we can stand up an Elasticsearch server on its own. So with all of that being said, let's take a look at the interiors of Liferay's search framework. And so Liferay itself has a search API that's used to do all of your kind of common classic search things, right? The search API is called upon within the search application or the search portlet. Alternatively, right, if we're connecting to a search engine, which we are, there will be an adapter that will bridge the gap between the search engine, like Elasticsearch, and Liferay's search API through this adapter. So we have this sort of layer of abstraction, kind of a middleman or middle layer between our actual search framework APIs and the search engine. So behind the scenes, this is our search architecture in a little bit more detail. Each one of these are the specific Liferay modules that are implementing search. So if you look at COM Liferay Portal Search, you'll find a number of different modules helping us out. Right? We have the Portal Search implementation, we have the Elasticsearch adapter, the actual search app or search portlet, and then we also have this faceted search. Our search API is over in Portal Impl, and over in the foundation of the foundation suite, we also have the Solr adapter. So for more information on some of this, we do have documentation as well as different areas in our repo that you can check out for the source code. Now let's talk a little bit more about search. So the first big aspect of search is indexing. So when we are indexing, the idea here is we take something, whether it's content that we're creating or a file that we have uploaded, and we are transforming it to a search engine index document. When you look at the code itself, you're just going to see document. So this is the index document. So every searchable asset type within Liferay is going to have this indexer extending the base index. So the indexer is going to not only help us create, or the indexer is going to be helping us retrieve that index document for whatever sort of entity, whatever it is that we are indexing. So analysis. So behind the scenes, what we're able to do is kind of process whatever it is that we are uploading. So this whole analysis process can run during the time that we are indexing something and during the time that we are searching for something. The process or the phases are kind of like so. So we first do character filtering. So we can pick and choose the different characters that we may not want, like the, or, and so on. Sometimes we want to keep those keywords like and, or maybe or a, to signify some significance. Whatever the case is, we're going to filter through our different characters, our different terms. From there, we're then going to tokenize what's left over. So maybe cat, dog, apple. All of these different keywords might be tokenized. Using some logic, maybe we might put them together. And then from there, we're going to filter through the tokens, right? So that we can do some further processing with what's left over. So we can do all of these things and we can configure how these things are going to be occurring. So how does indexing work? So we first submit an asset. So an asset is pretty much any sort of content within Liferay. So we submit an asset, and then from there, we will run our asset indexer. So, and if there's any indexer post-processors at the end, we can run those too. As we run the asset indexer to generate or get the index document, over in our search engine is where those three big processes can happen. So we can have our character filter, character filtering, tokenizing, and token filtering. All of that to help generate that index document. When we search for something, when we're sending a search query or asking to retrieve something, the results that come back to us are known as hits. So we will send a search query and the search engine will send back hits. So the search query analysis should match the index time analysis. So the amount of time spent between the two should be about the same. And then when we are searching, there's the idea of queries and filters. So we'll talk about each one. So a query is asking if the index document contains specific keywords that we are looking for. So if I'm looking for apple, orange, fruit, whatever, right? The query is going to check that index document and see, hey, is these keywords there or not? Right? In the query, there can be specific types, like it has to match exactly as is, or maybe there's a wildcard saying, this term and everything else that comes with it will be accepted as well. You can have operators, so you can say this and that, or this or that, or this but not that, right? To help kind of filter out. So filter queries in this situation are just kind of like regular queries, but they work in a filter context. The idea here is we're asking specific yes or no questions, right? If it meets this condition, yes. If it doesn't, no. So this could be used, for example, to filter out a number of results from a specific site, right? When we're dealing with search results, there is a score behind the scenes, right? Once we hit a specific score, or once we reach a specific score, this can then be seen as a hit and sent out. So filter queries do not affect the scoring mechanism. What's nice about filter queries is that they're faster than our regular queries that we just talked about. So whenever possible, we prefer using those filter queries. So search behind the scenes. So we submit a query, and then the search portlet might build the query, and if there's any index or post processors, we will run those. We send that query over to the database, and it's going to do a little bit of the filtering that we've seen before. It'll figure out, okay, what is it that's acceptable, what is a hit, and then it sends the results back over to Liferay. We will then process through the hit any sort of filtering we want to do, or any last minute processes we want to take advantage of. We can before displaying the results or the actual hits back to the end user. So with all that, how do we customize the process behind the scenes? So we are able to customize the index settings and type mapping within system settings of the Liferay control panel. Right? We can modify the front end and change the way our search portlet works, as well as how it looks. We can modify the hits behind the scenes with a hits processor. We're able to modify the indexing and the querying with one of our tools called an indexer post processor, right? And if we want, we can have a custom search engine adapter implementing the index searcher and index writer interface. That last one is, again, a little bit extra, but the other four are kind of big common use cases of when we would like to customize in the search engine or search in general. So index settings and type mappings, again, this could be found over in the UI under system settings. And this example here, we have a screenshot of Elasticsearch and how we can customize those things. So customize things like the analyzer, or customize how we handle specific words. Right? We can also change the type mapping to change the way our fields are indexed and index new fields if we wanted to. Now, one of the mechanisms we have is the indexer post processor. Right? It does kind of just as it tells us. When the indexer hits, we can do some things after the fact. So in order to do that, we would create a component that implements the interface indexer post processor, and then we would target specifically what sort of model do we want to hone in on before it gets indexed. So one example here, right? We implement the indexer post processor. Within the component annotation, we specify which specific entity we are going to target, and then from there, any sort of code that we're going to be executing for the search query in this example, we can go through. So a couple different use cases of the indexer post processor. We can modify the index document before it's sent off to the search engine. So index document may look like something. We can change it up a little bit using the indexer post processor. We can modify the queries before they are executed. So if we want to have some more robust queries, we can do that. And as the results are coming back over to the end user, we can change those up a little bit as well to control what the end user is going to see as a result. So another tool we have is the hits processor. So the hits processor, just like the indexer post processor, is going to be created as an OSGI component, but we're going to be implementing it using the hits processor interface. Right? The way that the processing order is defined is based off of a property sort order. So we'll see here the property sort order going to start us off at 0. In this example, this hits processor is going to go through and do a little bit of spell check, just kind of as the high level. So a couple use cases, just like what we saw before, we can, again, do something like spell checking or alternative search. The idea here is, if we don't reach a specific number of results, maybe we spelled something wrong, and maybe we can suggest an alternative spelling. We can do other things like process the results, do something before it's sent off to the UI. We can make some suggestions, just as we've seen in a lot of classical search engines. Search for something, you can get a list of other results or other search queries that might yield better results, and so on. So the default hits processor within Liferay. So we saw this briefly in code. The idea is just as we described. This will perform some sort of spell check if the result score is less than a specific number. So when it's less than a number, we can kind of assume that it's probably spelled wrong. So we have control over what that score is going to be. Right? We have also control over some suggested keywords as well. So, search for a specific keyword, Liferay or the search engine can throw back some other related keywords. So query indexing hits processor. The idea here is if our search query brings back a large number of results, or if it exceeds a specific quantity that we specify, we can index that result to retrieve it much faster. So the query suggestion, right? If we want to have a suggestion sent back over to the user that in the past has given us more results than what our current query has, we can do that as well. So you may have searched for something, gives you 5. We have seen that something similar has been queried, gives more results. We can then give that suggestion. So with all of that, let's go ahead. We'll move on to an exercise in which we're able to demonstrate our indexer postprocessor. So what we're going to do here is we're going to modify the search results summary by adding the modification date to the beginning of the summary. So we'll follow the same sort of template that we've done before. Create a Liferay module project using a generic template. We'll then create a component using our component class wizard, implement the class, deploy, and test it out. So with all of that, let's take a look at our indexer postprocessor.